Hi everybody. So in today's video, we're going to be learning lesson 9 and we're going to do the first part today, part 1, which is about L'Hopital's rule. We have two learning targets today. The first target is I can determine when a limit is indeterminate. Now this is going to be a review of something we actually practiced in Unit 1, which we're going to be connecting kind of limits and derivatives today. And one of the things we learned in Unit 1 is that there were some limits that we called indeterminate. So we're going to review what those are today. The second target for today is I can use L'Hopital's rule. So we're going to be learning a rule to evaluate a limit that is indeterminate in form. So once we know that a limit is indeterminate, in our previous unit, we were kind of forced to stop. We couldn't really solve that problem. In this unit, we're going to be learning that there is a rule that we can use to find the value of an indeterminate limit, and that's what we're going to be doing today. So let's start with a limits review, just a little bit of review of what we learned in Unit 1. One of the big rules about limits is the substitution theorem, which says that the limit as x approaches c of f of x is equal to f of c, provided that c is a real number. Now, in other words, what this means is that we can evaluate a limit by plugging in or substituting the x value that we are approaching in the equation we are given, provided that we get a real number as our answer. Now, what we said was that this sometimes works and it sometimes doesn't. So here's sometimes that substitution fails, where plugging in the number doesn't work. If we get 0 over 0 or infinity over infinity when we substitute our x value, we said in Unit 1 we were going to call that an indeterminate limit. If we get 0 over a number, so any number, it could be 0 over 5, 0 over 7, 0 over 100, that value is going to be 0 because 0 divided by anything is 0. If we get a number divided by 0, so 7 over 0 or 3 over 0 or 5 over 0, what we said is that we need to try numbers that are close to the x value that we want to substitute, because the only reason that that would happen is that there's some sort of vertical asymptote. So your answer is going to be either infinity or negative infinity, and we can figure out whether it's infinity or negative infinity by plugging in numbers close to our x value. For example, if x was supposed to be approaching 3, we said you could plug in like 3.0001, something close but a little bit bigger to see what's happening. If we get infinity divided by a number, so infinity divided by anything is just going to be infinity. Infinity divided by 2 is still infinity. And if we get a number divided by infinity, we're going to get 0. And the reason is because if you have 5 pizzas and you have to share them with infinity of your friends, everybody's only going to get a little tiny bit of pizza. So these were kind of the different situations where substitution didn't really work. We had to kind of think a little bit deeper about what was happening in those problems. What we're going to focus on today are the types of problems where we originally said that by substituting, we had an indeterminate limit. So we're going to be focusing on problems today where when you substitute, you get either 0 over 0 or infinity over infinity. In our original notes, when we learned this in Unit 1, we said that that was kind of a full stop. We didn't know how to solve those problems. That's why we called it indeterminate. The limit could not be determined. However, today we're going to learn something called L'Hopital's rule. L'Hopital's rule is a tool that we use to find limits that are difficult to evaluate algebraically. If direct substitution gives you 0 over 0 or infinity over infinity, then L'Hopital's rule states that the value of the original limit is equal to the value of the limit that you get when you take the derivative of the top and the derivative of the bottom and try to find that limit. So in other words, you can find the value of the original limit by finding the value of the limits of the derivatives of your original functions. Now, what I want to point out here is that even though our original problem had a fraction in it, that's how we got 0 over 0 or infinity over infinity, we're not using quotient rule to find these limits or to find these derivatives. We're just taking the derivative of the top, taking the derivative of the bottom, and finding a new limit. In order to use L'Hopital's rule and sort of show your work and receive full credit, you need to do the following things. Number one, you need to show that the original limit is indeterminate. So you have to actually show that by substituting, you get either 0 over 0 or infinity over infinity. You have to state that on your paper. This is something that a lot of students like to skip because they do the arithmetic or the math in their head, and that is not okay. You have to show this work on your paper. Then you have to say the words by L'Hopital's rule. So you have to say that you're using L'Hopital's rule, and you have to say that the limit that you originally had is equal to the limit of the derivatives. Finally, you can actually find the limit by just, using proper notation and showing your work. Let's go through a few examples here so you can see. This is actually what I think a very helpful solution for some of those indeterminate limits that we weren't able to do before. So problem number one is polynomials and powers. We're going to do 3 of these examples where we're going to do kind of polynomials and different power functions and show how we can use L'Hopital's rule. So the first step of L'Hopital's rule is try direct substitution, just like we did in Unit 1, and show that we get either 0 over 0 or infinity over infinity. In problem number 1, if we try direct substitution, we get 2 times 5 squared minus 9 times 5 minus 5 all over 5 minus 5. Now, 5 squared is 25, so 2 times that is 50, minus 9 times 5 is 45, minus 5 gives you 0, over 5 minus 5 is 0. Now, that means that we have an indeterminate form, so we need to actually state that. We need to state that this is indeterminate in order to show why we're using L'Hopital's rule. We've met the conditions. We have an indeterminate form, therefore we can use L'Hopital's rule. Then you're going to say, by L'Hopital's rule. And you have to actually state that. This is not like optional. You have to say that you're using L'Hopital's rule. And then you're going to say the original limit that we were trying to find must be equal to the limit as x approaches 5, the same value, but this time of the derivative. So first, we would find the derivative of the top. And again, I'm not using quotient rule. I'm just doing 2 separate derivatives here. So it would be 4x minus 9. And then we would find the derivative of the bottom. And again, I'm not using quotient rule. I would just take the derivative of the bottom, and that's just 1. So you're showing that you have an indeterminate form, which is the condition. You have to have it 0 over 0 or infinity over infinity. And then you're saying, I'm using L'Hopital's rule, which says that the limit that we originally had is equal to the limit of the derivative of the top and the derivative of the bottom. Now we can just direct substitute again. So if we directly substitute again, we get 4 times 5 minus 9 all over 1, which is just going to be 11. So that would be your answer. Again, I think L'Hopital's rule is a kind of a nice, neat way for solving a lot of these problems. Let's try the next problem. So in the next problem, if we substitute, we would get the square root of 4 minus negative 5 minus 3 all over negative 5 plus 5. Now, if I simplify that, the square root of 4 minus negative 5 becomes plus. So the square root of 9 is 3 minus 3 is 0 over 0, which is an indeterminate form. And the reason, again, that you need to show that is that you're showing you've met the conditions for L'Hopital's rule. It has to have an indeterminate form when you try substitution in order to be able to apply L'Hopital's rule. So by L'Hopital's rule, the original limit that we had, limit as x approaches -5, of the square root of 4 minus x minus 3 all over x plus 5 has to be equal to the limit as x approaches -5, and then we're going to take the derivative of the top and the derivative of the bottom. So in this problem, the derivative of the top is going to require me to use chain rule. As a reminder, a square root is really a 1/2 power. So we have 4 minus x to the 1/2 power here, minus 3. The derivative would be 1/2 times, leave the inside alone, 4 minus x to the negative 1/2 power. You're just subtracting 1. And then times the chain, which would be -1, because there's an invisible -1 here by the x. Now, the derivative of minus 3 is 0, so there's nothing else to put here on the top. You're done with the top derivative. Then you would do the bottom derivative, which is just the derivative of x plus 5, which is 1. After you do that, you can just substitute your value again. So in this problem, we would have, I'm going to combine the -1 and the 1/2. So we would have -1/2 times 4 minus -5 to the -1/2 power, which means we have -1/2 times 9 to the -1/2 power. Now again, I think it's easier to evaluate this if we rewrite this without having a negative exponent or a fraction exponent. So the negative exponent tells me to move that 9 to the 1/2 power to the denominator, and a 1/2 power is really a square root. So we really have the square root of 9 in the denominator. The square root of 9 is 3, so if we simplify, we get negative, and it would be 1/6. In this problem, I think the hardest part, for me at least, is going to be the finding the derivative here using chain rule and then the evaluating part. Last but not least, let's try a problem that has like exponential and logarithmic functions. So first, let's try direct substitution. We would have the natural log of 1 minus 1 plus 1 all over e to the 1 minus e. Now the natural log of 1 is 0, and -1 plus 1 is 0. So you'd have 0 on the top, and then e minus e would be 0 on the bottom, which means that this limit is indeterminate. Once we've determined and established that the limit is indeterminate, we can say that by L'Hopital's rule, the original limit, the limit as x approaches 1 of the natural log of x minus x plus 1 all over e to the x minus e must be equal to the limit as x approaches 1 of the derivative of the top and the derivative of the bottom. So let's start by finding the derivative of the top. The derivative of natural log would be 1 over the stuff. The derivative of negative x would just be minus 1. And the derivative of 1 would be 0. So that's the derivative of the top. And the derivative of the bottom, the derivative of e to the x would just be e to the x. And since e is a number, albeit an irrational number that we're not usually used to working with like a number, e is just a number, so the derivative is 0, so you're done. Now the next step would be again to try direct substitution. So you would get 1 over 1 minus 1 all over e to the 1, which gives you 0 over e, which 0 divided by anything, that's just a number, is just 0. So it would be 0. Okay, so that's kind of 3 examples of how we can use L'Hopital's rule. Now, the next follow-up is that sometimes we need to use L'Hopital's rule more than once. So we're going to look at some problems that involve using L'Hopital's rule repeatedly, so more than once. Let's try this first problem. We're going to start the same way, direct substitution. So if we try direct substitution, we get negative infinity squared over e to the infinity, which gives me infinity over infinity, which is indeterminate. Just like before, we need to establish that we have an indeterminate limit before we can apply L'Hopital's rule. Then we would say, by L'Hopital's rule, the original limit as x approaches negative infinity of x squared over e to the negative x must be equal to the limit of the derivatives as x approaches negative infinity. So if we take the derivative of the top, we get 2x. And if we take the derivative of the bottom, this is going to involve using chain rule. So the derivative of e to the x would be e to the negative x times the derivative of the exponent, which is just negative 1. Now when we try direct substitution again, we get 2 times negative infinity divided by negative e to the infinity, which would be negative infinity over negative infinity. Once again, we have a value that is indeterminate when we try substituting. Once you've applied L'Hopital's rule, if you get another answer that's indeterminate, then you can apply L'Hopital's rule again. So by L'Hopital's rule, so you have to say it again, this new limit, the limit as x goes to negative infinity of 2x over negative e to the negative x. So it's this new limit that we started with. Now we're going to take the derivative again. So now we're going to be working with the second derivative of these functions. The derivative of the top would be 2, and the derivative of the bottom would be negative e to the negative x and then times negative 1 again because of the chain rule. So the derivative of e would just be e to the negative x and then times the negative 1. Now when we try direct substitution, we get 2 divided by this negative times this negative makes a positive, so it would be e to the infinity, which makes 2 divided by infinity, which is 0. So what we say is that for a problem like this, we can use L'Hopital's rule repeatedly as long as we continue to have indeterminate forms when we attempt direct substitution. Let's try the next example. So for the next example, if we try direct substitution, we get negative 2 to the third power plus negative 2 to the second power minus 8 times negative 2 minus 12 all over negative 2 to the third power plus 8 times negative 2 squared plus 20 times negative 2 plus 16. Now, if we simplify this, this is going to be negative 8 plus 4 minus or plus 16 minus 12. So that's going to be 0 over, and then on the bottom, we're going to have negative 8 plus 32. So that's going to be 24 minus 40 plus 16 is going to be 0. So 0 over 0 is an indeterminate form for a limit, which means we can use L'Hopital's rule. So we would say, by L'Hopital's rule, the original limit that I was trying to find, the limit as x approaches negative 2 of x cubed plus x squared minus 8x minus 12 over x cubed plus 8x squared plus 20x plus 16 would be equal to the limit of the derivatives of those functions. Now the derivative of the top here would be 3x squared plus 2x minus 8, And the derivative of the bottom here would be 3x squared plus 16x plus 20. Now when you try substituting in -2, you get 12 minus 12, so you get 0 over, and this would be 12 over 0 again. Again, we have a limit that is indeterminate. So once again, we're going to apply L'Hopital's rule to find the value of the limit. So we would say by L'Hopital's rule, the value of this new limit that we were trying to find after we took the derivative, the limit as x approaches -2 of 3x squared plus 2x minus 8, all over 3x squared plus 16x plus 20, is equal to the limit as x approaches -2 of the derivatives. So the top would be 6x plus 2, and the bottom would be 6x plus 16. Now, if you try direct substitution again, you get -12 plus 2 is -10, and -12 plus 16 is 4. So that simplifies to -5 over 2, which is your final answer. Last but not least, if we try the problem in the last example, if we start with direct substitution, we're going to get 9 times infinity squared plus 10 times infinity minus 3, all over 12 times infinity squared minus 4, which is going to give us infinity over infinity. So that would be indeterminate. Because this is an indeterminate limit, we can apply L'Hopital's rule. So to show our thinking, we would say by L'Hopital's rule, the original limit that I was trying to find, the limit as x approaches infinity of 9x squared plus 10x minus 3, all over 12x squared minus 4, would be equal to the limit of the derivatives. So the derivative of the top would be 18x minus 10, and the derivative of the bottom would be 24x. Now if we try direct substitution again, we once again get infinity over infinity, which is another indeterminate limit. So L'Hopital's rule says if it didn't work the first time, just try it again. So by L'Hopital's rule, this new limit that we were trying to find, the limit as x goes to infinity of 18x minus 10 all over 24x, would be equal to the limit of the derivatives. So it'd be 18 over 24. Now there's no place to substitute infinity. So we can just say that the answer is 18 over 24, which simplifies to 3 over 4 because both the numerator and denominator are divisible by 6. All right, this is our short introduction to L'Hopital's rule. We will be looking at some more complicated questions over the next few days, but I hope that this made sense, and I will see you for some practice in class.